Hi, I would like to share an interesting geometry problem here. So this is the figure. When I first see this problem, it seems quite simple, but you may have to try first. This figure consists of semicircles. Right? So there are four semicircles, all of the diameters on one line, A, B, C, D. And the shaded area, we're going to find the shaded area, right, given the length of AC and the length of BD. So is that enough for you to find the area of this figure? Maybe you can pause for a while and see how you understand it before you move on. So if you have tried to think about this, perhaps you notice that there's something interesting about this figure, right? So you may wonder, do we need to find the length of BC in order to calculate the area of the shaded part, okay? And if they're not given, if the length of BC is not given, does it mean that it doesn't matter, right, what the length of BC is, or you can find out the length of BC from the given information now? But I think just based on the length of AC and BD, you can't tell the length of BD. Sorry, you can't tell the length of BC. For example, if I put it closer together, then you can see that it is the same information. AC is 10 and BD is 18, right? But now BC is longer. Or you can make BC shorter, or even become zero in an extreme case like this. So does it mean that no matter how I move this point D forward, left or right, the figure will have the same area? So that is the basic question perhaps you have to answer. In fact, you can have a try. You can try some specific values of BC. Let's say you can take BC equal to 2 cm or 3 or 4 and then calculate an area and then try to confirm whether the area is the same or not. Okay? So after you have a trial, then maybe you can go further, think about how to shows that the area can be found just based on the length of AC and BD. So I have another file to show a little bit more information. You can click the link below to see more about this. Yes, this figure may provide a little bit more detail. Okay, so I break down the length AD into these four parts: 17, 3, 5, and 9. Okay, so with this individual length, perhaps you can quite easily find out the area based on these expressions. Right, so this is just based on what you know about the areas of semicircle, and combined together you get this area. So can we have another way of finding the area if we have only limited information, just the length of AC and the length of BD? So maybe you can further think about it before I go on to explain it. So once again, you can also pause for a while here and have a try it first. Okay, so if you have also tried some of your own way, see how far you can simplify these expressions or try to understand how this expression can be transformed into another form. Now, this is my suggestions, right? Actually, you can see that you can shows that these calculations give the same value, right, of the area, which actually depends on only AC and BD. Of course, we can't easily get this expression directly from the first expression. It may require some lengthy algebraic manipulations, right? Then you can further try it later. But at least you can see the value if you really try to use the calculator, okay? And then adjust this value, and then you can find that these two calculations give the same numerical value. So we suggest that they may be equivalent. So if you, right, so if you believe this result, then you may go on to think about it, how to transform the first expression into the second one. What algebraic skills will you need, right? And so if you want to have a try before you move on, you can take a pause again. So I just write down briefly the major expressions here. The first one directly from the calculations of the area of the semicircle, and the second one may be obtained if you try some simplification, right, which may not easily know at the beginning, okay? So you have to really go into the expressions and then try to transform it and see what like. Now, I have some suggestions here, and you can have a look. Maybe your expression is different from mine, or you have another method, and feel free to share with me. I would like to hear what other method you may consider. So if you click on my link here, then you will find my algebraic expressions. So that is the first one I tried. Just mark the same value again in the figure. And so we start with these expressions. about calculating all the semicircles. I think the first step probably can be quite easy. You just take out the common factor 1/4, and what's behind will be these 4 expressions, including the squares, okay? The squares of the diameter. Perhaps up to this part, you will also try the identity difference of 2 squares, right? Because this 2 is a square and this 2 is also a square, and see what they look like. So why not have a try and then see this part can be factorized into 2 factors, AD minus AB and then AD plus AB. Now, it may not be immediately obvious what you can do for the next step, okay? But if you go back to the figure, then you could find out AD minus AB, okay? AD minus AB is just BD, okay? So this will be easier only if you refer to the figure again to find out how some of these factors can be transformed or simplified. So it so happens this part is BD and this part is also BD, right? So we are quite lucky if you see this, and then perhaps you will now further take out the BD as a common factor and see what's left behind, right, as a remaining expressions. Any hints of simplifying it? Well, it may not be too difficult. Perhaps you can also go on to try it, and then you will find that, but you need a little bit rearrangement. For example, AD minus CD becomes another segment AC. And on the other hand, AB plus BC will become another segment AC. So both of them are just equal to AC. So you can consider as just 2AC. That's why the final expression can be rather simple and just leaving behind the segment BD and AC. So I don't know how far you can follow easily these expressions and also referring to the combinations of the segments. If you think that it may be difficult to read, I suggest another way of writing the expressions. I can't tell which one is simpler, but you can also have a try and compare. I just label the AB as 2P and BC as 2Q and CD as 2R, and then go on with the same calculations again. And this time the expressions will be in terms of PQR. Right? Yes, just PQ and R, the 3 segment. But after some rearrangement, right? So the first one, you can see that this is also the square, the difference of 2 square. Right? So you can rearrange in this way. And the second part, Q square R minus R square, can also be rearranged in this way. So you can see the Q plus R becomes a common factor that you can take it out. And then you can go on to rearrange the rest. And later on, notice that the expressions can be neatly put it down in this way, just Q plus R and P plus Q, right? And then you can refer to the figure to find out what they are referring to. So here is, maybe you can transform these expressions a little bit. Okay, so this is my suggestions. So you can have a try. And then one more final extensions of questions. So what makes it interesting is that this figure, actually the area, just depends on the length of AC and the length of BD. That means no matter how you change it, either this way or this way, you get the same area. How about if I further move D to this size? So do you think the area is still the same? This can be an extension for you to further consider.